Hello. In this video, I'm going to be explaining problem 1 from the 2012 F equals MA contest. In this problem, we have a dripping faucet where the faucet is 10 centimeters above the sink. And the time between drops is such that when one drop hits the sink, one is in the air and another is about to drop. So in this case, what we have is that one drop will be right here, hitting the ground, one will be about to drop, and one will be somewhere in the air. And the drops are evenly spaced, or in time, because that's the only way for this pattern to always be the case. And so the question asks, what is the height of this drop right when this drop that was right before it hits the sink? So we can do this using relatively simple kinematics equations. So suppose that the time between drops is some time t. So this will be time t. Then what we have is 1/2 gt squared. So the displacement of the drop will simply be 1/2 gt squared because it starts from rest, and we can say that if this is position 0 and then this is position h and this is the positive direction downward, then the displacement will be 1/2 gt squared in the amount of time t, where t is the time between drops. And so that will equal h minus big H, but we know that 1/2 g times 2t, the whole thing squared, is just the time for this drop to fall all the way down to the sink, and that will just be the total height h. Now from these two, we can see that this quantity is just 4 times as much, and so what we see is h is equal to 4 times h minus h, and so this h, big H, is just 3/4 times little h, which is 7.5 centimeters. And so the answer, we can see that capital H is between 6 and 8 centimeters. And that's all there is to this problem. All right, I hope that was helpful. Thank you for watching.